Good day to all. I'm honored to present my paper 2633 AI-powered health insurance fraud detection using QEM-FusionNet based SmartGridRand on 2025 IEEE International Conference on Artificial Intelligence in Engineering and Technology, organized by IEEE and co-hosted by Universiti Malaysia Sabah. Here, I need to introduce my paper with the challenges which we are facing right now and the upcoming, our approach to reduce that challenge. Healthcare fraud imposes a significant financial and operational burden on insurance providers and healthcare systems globally. Fraudulent claims not only lead to massive economic losses but also compromise the accessibility and quality of care for legitimate patients. The advent of AI and ML has facilitated the development of intelligent fraud detection systems capable of analyzing historical data, uncovering hidden patterns, and generalizing to unseen instances. This research suggests a novel hybrid ensemble model to overcome these constraints. QEM-FusionNet-based SmartGridRand, which integrates multi-layer perceptron, extra trees classifier, and quadratic discriminant analysis within a stacking ensemble framework. This study's main contributions are QEM-FusionNet, which is a novel stacking ensemble model that integrates MLP, extra trees, classifier, and QDA, utilizing their complementary learning capabilities to improve the effectiveness of fraud detection. And one more thing, it's QEM-FusionNet based smart grid RAND, an efficient hybrid hyperparameter tuning strategy combining randomized and grid search to improve generalization and minimize training overhead. And these are all the papers I have used and mainly contributed the idea of to introduce this paper to all, like the one by Sulaiman Sadar, which is for cyber attack and fraud detection using ensemble stacking. And this demonstrates the robustness of ensemble stacking models in noisy data environments for both cyber healthcare fraud detection, concluding that stack classifiers enhance model resilience. And Ashrat proposed a deep learning framework using CNN to detect forged medical images in insurance claims, highlighting the capability of deep models to uncover complex fraudulent patterns. And Anubama investigated medical fraud detection using traditional supervised learning models combined with feature engineering, emphasizing the effectiveness of well-tuned decision tree based models. Talukar introduced a multi-stage ensemble approach integrating stacking and boosting to address class imbalance in financial fraud detection. Similarly, Honk modeled a contextual fraud relationships between entities such as patients and providers using multi-channel heterogeneous graph structure learning, which significantly improved detection accuracy. Here, I would like to propose my methodology, and this study proposes an effective and robust system for detecting fraudulent healthcare claims using a hybrid ensemble learning model named QEM-FusionNet based Smart Grid RAND. The model is developed using a publicly available healthcare fraud dataset containing anonymized provider-level claim data, including patient demographics, diagnostics, codes, procedures, details, reimbursement amounts, and a binary label that indicates the falsity of a claim. The QEM-FusionNet model integrates three diverse classifiers such as MLP, extra trees classifier, and QDA within a stacking ensemble framework, wherein a meta classifier is trying to combine their outputs to make the final decision. This combination leverages the nonlinear learning capacity of MLP, the ensemble robustness of extra trees, and the statistical discrimination capability of QDA To further enhance predictive performance and generalization, a two-phase hyperparameter tuning approach called SmartGridRand optimization is introduced. In the first phase, the hyperparameter space can be thoroughly explored using randomized search cross-validation, followed by grid search cross-validation in the second phase, to fine-tune parameters in the most promising regions. To address significant class imbalance, randomized undersampling is applied to the majority like non-fraud class, which improves the sensitivity of the model in identifying instances of fraud. This is the architecture of the proposed solution, which combines of input data collection from the healthcare provider fraud detection analysis dataset, which I have mentioned earlier, and from the data collection we are processing it like missing value handling, label encoding, aggregation, normalization, and class balancing. After that, it moved to the feature extraction using PCA. As I already mentioned, it is going through this PCA process and this smart grid and optimization using two phases. After that, it is going to the proposed QEM-FusionNet based smart grid RAN model, which classifies whether the claim is fraud or non-fraud. This is how the architecture works, and this is to guarantee consistent scaling across all inputs, numerical features, and are standardized using the standard scaler. And the confusion matrix based on our proposed solution is suggested like here. According to the matrix, the vast majority of claims, both false and not, are correctly classified. With low false positive and false negative counts, this indicates minimal misclassification and high reliability of the model in practical applications, where reducing both undetected fraud and false alerts is crucial. With an area under the curve of 1, the receiver operating characteristics curve is demonstrate the discriminative power of the model. This ideal score confirms the model's exceptional capability in separating claims that are fraudulent from those that are not, while preserving a high true positive rate and reducing false positives critical for real-time fraud detection. And this shows the accuracy and precision of our model, which we have right 0.98 comparative with logistic regression, random forest, XGBoost, and MLP. And this is the precision value based on the comparative analysis. Here is the recall and F1 score for comparative analysis based on the values which we have arrived based on the QEM-FusionNet and SmartGridRand proposed solution. And this, I would like to conclude, this study introduced QEM-FusionNet based SmartGridRand, a robust hybrid ensemble learning framework for healthcare fraud detection. By integrating neural ensemble and statistical classifiers within a stacking ensemble architecture, the model leverages the complementary strengths of diverse learners to effectively handle complex, noisy, and imbalanced healthcare data. The inclusion of smart grid RAND optimization, a two-phase hyperparameter tuning strategy that combines randomized search and grid search, ensures optimal model performance while maintaining computational efficiency. The proposed model was rigorously evaluated on a real-world healthcare claims dataset, demonstrating superior performance across all key evaluation metrics, which is accuracy, precision, recall, and F1 score, compared to traditional classifiers. The results validate the system's practical utility in accurately identifying fraudulent claims, offering a scalable and adaptable AI-based solution for deployment in commercial insurance environments. Future work can explore the integration of real-time fraud detection capabilities and the incorporation of explainable AI techniques to enhance the interpretability and transparency of automated decisions, thus increasing stakeholder trust and regulatory compliance. Thank you to all.